Okay, start at chapter 4. We're going to be looking at quadratic functions in chapter 4. So we're moving away from the linear functions, all things linear. And of course we did absolute value, which is like two linears put together. But now we're going to do a quadratic. When you know you have a quadratic, if you have a degree of 2, and that means that you've got an x squared basically. The biggest exponent is 2. So quadratic functions, a lot of word problems that go with it, but the one we use most often is when you have something that's affected by gravity, you throw a ball, that type of deal there. So we're going to go ahead, we're going to identify and graph quadratic functions today. The graph of a quadratic is called a parabola. You might remember that. We discussed that this year a little bit, and that is U-shaped. The graph opens up, the leading coefficient, that's the number in front of the x squared, is positive, opens down, the leading coefficient is negative. That goes with our transformations. You got a negative in front, that tells you to reflect over the x, so that would make everything move down. Positive, you're going to have this u that opens up. Just like absolute value, the highest or lowest point is called the vertex. And just like absolute value, you've got an axis of symmetry, and it's going to go through the x coordinate of the vertex. Well, that's how you find the axis of symmetry. So I say the x coordinate, I mean obviously it goes through the y of the vertex as well, but it goes through the vertex. The x coordinate gives you the axis of symmetry. You'd say x equals and then whatever the x coordinate is. So like if you had a vertex of 3, 4, you would say x equals 3 is your axis of symmetry. Graphing the parent function. Your base function y equals x squared. We've actually done this before, so nothing new here. Which way does it open? It's a positive x squared, so it opens up. Since it opens up, it has a low point. The lowest number I could get would be y equals 0, and that's when I plug in x equals 0. I can't get any lower than that because there's no way to get a negative when I square something. If I plug in x is 1, I get 1 squared is 1. If I plug in x is negative 1, I get negative 1 squared is 1. If I plug in x is 2, I get 2 squared is 4. And if I plug in x is negative 2, I get negative 2 squared is 4. So if I was going to make a t-chart that had the values that I just discussed, look like this, and there's my u that opens up. The axis of symmetry, as I said, is a vertical line that goes through the vertex, and you can identify it by saying x equals whatever the x coordinate of the vertex is. In this case is 0. So there's our parent function. Anything else is a transformation of that parent function. So the next problem, I say use transformations to graph this. So if I want to use transformations, I could make a chart like I just had there. I could use these starter points. And then I could say, all right, what happens here when I look at my transformations? Well, if I look inside the parentheses, first, that's order of operations, that tells me to go right 1. So that means add 1 to all my x's. So now my x's become, what's right 1 of negative 2? Negative 1. What's right 1 of negative 1? 0. And then these all go up by 1. So that would be my new set of points there. So that would take my parent function here, and that would move everything on the parent function to the right 1. Just trying to group those points with it, so if I want to move them, they go with me, but it's going to change in a second anyways. You know, yeah, that'll be all right. Group that. Move that back into place. Now everything should move with it. So, oh, I thought I had that with it too, but I don't. So that goes right 1. That goes right 1. Missed the 0, 0. Oh well. Hopefully you get the idea. And you can see now that if I plug in -1, I do get 4, -1, 4 is right there. If I plug in 0, I get 1. Here's 1, 0. Here's 2, 1. And here's 3, 4. Okay? Now, what would I do next? Well, it's -2 in front is multiply. That's the next thing. Well, the -2 is actually two transformations. It's a reflect over the x, which changes your y. If you go from a high point to a low point down here, that just changes the y. There my x is on both of these points right here. X is 3. But the y switches. Up top it's 4, and on the bottom it's -4. So I'm just switching y. The 2 tells me it's a vertical stretch of 2. Vertical affects the y. That tells me to multiply by 2. So -4 becomes -8. -1 becomes -2. 0, -2, -8. And finally, the +4 at the end, that moves the whole thing 4 up. That affects the y. We don't do much that affects the x. It's right and left. There is some horizontal stretching and shrinking that you can do, but you won't cover that until pre-calc. Everything else we do affects the y. So what's 4 up from -8? -4. 2, 0 plus 4 is 4. 2, and -4. So here's where your new points would be on your graph. -1, -4. I'll graph that over here. 0, 2, 1, 4. That's my vertex. 2, 2. And then 3, -4. So hopefully you can see that transformations, how they worked with what we applied here. This thing flipped over the x. It looks skinnier because of that vertical stretch. And then the vertex got slid up. The vertex was on the x-axis. So here's my vertex on the x. Well, now my vertex is up 4 from there. That was the slide up that happened. Okay? So that's using transformations. So which way does it open? Down. What's the vertex? That's our 1, 4. That's our top point in this case. And then the axis of symmetry is x equals, what's the x equal? 1. Again, it's always x equals because it's a vertical line, and it's the x coordinate of the vertex, so x equals 1. I wouldn't graph these using transformations. We can be a lot quicker than that. I'll show you, I think, on the next slide here. Okay, so you can graph by using transformations or by starting with the vertex. So here's vertex form of a quadratic. Y equals, you've got some number in front, call it A, times the quantity x minus h, quantity squared, plus k. And I say hk is the vertex, and hopefully that makes sense to you because this would tell me to go h units right or left, I guess, depending on if it's positive or negative. You don't know if h is positive or negative based on this. So h units right, left, and then you'd go k units up, down, depending on if k is positive or negative. So hk is your vertex. Then just find another point on each side, and finding the y-intercept is commonly found. So how do you find the y-intercept? Plug in x equals 0. So I've got two graphs here. I think I was going to do one with transformations, one with just finding the vertex and going from there. I think I'm going to move this off to the side. I'm just going to do one over here. I'm going to find the vertex. Put V for vertex. The vertex is whatever makes the inside equal 0, so that'd be -3. Up there it says x minus h, and down here it has x plus 3. Well, that's the same as x minus -3, so it's -3. If you want to put it in x minus form, you'd have to change it to a -3. So our vertex is at -3, and you can see that if I plug in -3 right here for x, it makes this 0 and it cancels everything out right there. Except for the end number, which is my k, -4. So my vertex is at -3, -4. We'll go ahead and plot that, -3, -4. I can see this thing's going to go up. Now carefully, you can't use the, like on absolute values, we just go ahead and use that 2/3 and treat that like slope. That doesn't work here. There is a little trick where you can make it work, but it doesn't work consistently. Parabolas don't have a constant rate of change. So the slope, there isn't a slope. The slope is ever changing, so to speak. So in this case, the slope, it's always going to get steeper. It might start off as something, but then a little bit later it gets bigger and bigger and bigger. So what I would do then is you can find the y-intercept by plugging in x as 0. So let's plug in x as 0. Let's see what happens. You get 2/3 times 3 squared minus 4. If I put a 0 right there, 0 plus 3 is 3. You'd have 2/3 times 9 minus 4. 3 squared is 9. 6 minus 4. 2/3 times 9 is 6. 2. So when you plug in 0, you get 2. Well, there's a line of symmetry, excuse me, right here. So what that means is if 0, 2 is a point on there, then there's got to be a point right over here as well. 3 away from that line. Has to be equidistant from that line at the same level. So I had 0, 2. That tells me that -3, or excuse me, -6, 3 left of -3, -6 and +2 is also on the graph, and then you can draw your U. Okay? You didn't have to find the y-intercept. If you want to plug something else into the right, you want to plug in x is 1, go ahead. If you plug in x is, x is -2, because -2 is just to the right. You could plug in x is -2 and find out what level that's at. And then reflect that over the axis of symmetry. And so as long as you get 1 point on each side, you're good to go. Just know that the book likes to find that y-intercept by plugging in x is 0. So which way is it open? Up. What's the vertex? -3, -4. Axis of symmetry, x equals -3. Writing a quadratic in vertex form. A baseball player hits a ball when it's 3 feet above the ground. I'm going to draw a picture here. I can do that on word problems. The ball reaches a maximum height of 100 feet after being in the air for 2 seconds. Write a quadratic equation in vertex form that represents how high the ball is. And I guess that would be measured in feet. So let's say height, feet, that's my y, after so many seconds, x. So down here we'll have time, and that's measured in seconds. Well, I know that at 2 seconds it's at 100, so I'm just going to go 1, 2, it's up here, I'll just say this is 100. So that's the max height. And another thing I know is that it's hit at 3 feet above the ground. So I know another point on here, I'll say right here, is 3. 0, 3 is on there. So that's what the 3 feet above the ground tells me. This tells me that 0, 3 is a point on the graph. And this info right here tells me that 2, 100 is a point on the graph. And not only is it a point on the graph, it is the vertex because it's the highest point. Anytime you have something affected by gravity, it's going to take a parabolic path. And looks like let's see if I can redraw that a little bit. I can't go back. I'm not real happy with how my parabola took shape here. All right, a little better. But you're affected by gravity, you're going to take a parabolic path. So what do I have going on here? I want to get this in y equals a times x minus h quantity squared plus k form. Well, I know that hk is 2 and 100, so I know this much so far. X minus 2 quantity squared plus 100. What I don't know is the a. So I need to find the a. And here's how you can find the a. Just plug this other point in. So I know that 0, 3 is supposed to work. So let's plug in 0, 3 to find a. So if I plug in 0, 3, it's going to look like 3 in for y and 0 in for x. And now if I solve for a, I can finish off my equation. This will end up being 4, because negative 2 squared is 4. So I have 3 equals 4a plus 100. Solve for a. So negative 97 equals 4a. So negative 97 over 4 equals a. Now I have my equation. In order to come up with my equation, I needed a, h, and k. So here I was almost done. I had 2 of the 3. I just need to go ahead and plug in the third. It would be negative 97 fourths, x minus 2 quantity squared plus 100. So that's how you find the equation in vertex form if you know the vertex and you know another point. Plug in that hk, and then plug in that point so you can solve for and find a. Any equation represents the graph of the parabola given. Negative 1, 6 is the point on the graph. So I told you negative 1, 6 is on here. Right here, just to be clear as to what's going on. Hopefully we can tell that there's a vertex right here. And I would say that vertex is negative 2, 3. So this is just practicing the last skill that I just went over. We're going to try to plug in to our standard or our vertex form of a quadratic. And so far I know that it's h is negative 2 and y is 3. So instead of x minus 2, I should put an x plus 2 in here and then a plus 3. Okay? So when the vertex is negative 2, I put in x plus 2 right there. That way when I plug in a negative 2, it goes away. Negative 2 plus 2 is 0. Now I need to find a. In order to find a, I'm going to take this other point and plug it in. Y is 6. X is negative 1. Equals a plus 2 squared plus 3. Okay, so I just plugged in negative 1, 6. And 6 equals a times 1 squared plus 3. 6 equals a plus 3. 1a plus 3, if you will. 1 squared is 1. So a is 3. And now I can go back up here and I can finish my problem because the only thing I needed was a. So y equals 3 times the quantity x plus 2 quantity squared plus 3. That's that parabola in vertex form. Okay, and just practicing the skill, 5 and 6 is doing the exact same thing. I'll do one more. I don't know if I want to do 6. We'll see how much time. We're getting at that 19 minutes, so I guess I'll go through really quickly here. Vertex is 3, negative 4. So it'd be x minus 3, quantity squared, minus 4. That equals 8. Plug in the point. So I'm putting in 5 here, I'm putting in negative 1 there. So 5 equals 16a minus 4. 16a minus 4 because it would be negative 4 squared. That's 16. That's what this would be. So 9 equals 16a. So a is 9/16. And my answer is y equals 9/16 times x minus 3, quantity squared, minus 4. Well, let's see, last one, I guess I can go really quick. I would pause it if I were you right here, see if you could get it right, and then run it again, see if you get the right answer. So I found out A is -7/25. So my answer on this one, -7/25 goes in front. And I end up with -7/25 times the quantity x plus 1, quantity squared, plus 10. So there's your intro to solving and identifying quadratic equations, particularly in vertex form. Thanks for watching. Have a great day.